Everyone, welcome to video 6E. This is talking about tangents to circles, and this is coming from section 10-5 of your textbook. So for our first term, of course, we're going to define this idea of tangent. That's T-A-N-G-E-N-T, just like we use tangent in trigonometry, only we're not talking about a ratio anymore. This time we are talking about a line or a line segment that intersects a circle, and this is the most important thing about tangent, that it intersects the circle in exactly and only one point. So a picture for this is going to look pretty simply just like a circle, and then with a line cutting right through one side there. So when we talk about tangent, we also want to talk about the next vocab term, which is point of tangency. And when we talk about point of tangency, we are talking about the specific point where a line and a circle, or possibly two circles, just that one point where they touch or where they intersect. And we'll show you some examples of that. Of course, on this diagram, we'd be looking just for this one point right there to be the point of tangency. But if we had another example, we could also put where two circles were touching at just one point, and we could say that that would be a point of tangency in the middle. Sorry, that's a bad diagram, but you get the idea. Gotta love my stylus. Alright, so if we move on to the next theorems that we're going to be working with in this section, and again, you do not need to know these by name, I hope you know that by now. But we got theorem 10.9, and that is talking about if we have a line that is tangent to a circle, so this is important to realize at this point because we have the word tangent here and we have the word tangent back here, so you need to know that the term tangent can be both a noun and an adjective, meaning, remember, it's a thing, but it also can describe, like it does right here, how something relates to something else. So if a line is tangent, meaning it touches in only one spot, to a circle, then we can say that it is going to be perpendicular to the radius that is drawn out to, sorry, let me try that again, drawn to the point of tangency. And I'll just abbreviate that, point of tan. So here's what that picture looks like, you guys. We've got a circle, we've got a tangent, and if we draw a radius from the center to that point of tangency, then this theorem 10.9 says we can always assume that that tangent is going to be at a right angle. Okay. Our next theorem, and we will use these theorems in the next video, so don't worry if we don't quite understand them right now. They'll make sense once we start practicing examples. But theorem 10.10, the next one, is just the converse of theorem 10.9. Okay, so that just, remember, switches the if and the then statement. So this time, what we know to begin with is that if a line is perpendicular to a radius, then the line is tangent. And that's using tangent as an adjective in that spot. Okay? Not really a picture to go along with that that's any different from the theorem 10.91, so we'll leave that one as is. The next theorem and the last theorem that you need to know as new for this section of notes is theorem 10.11. And that talks about two segments being tangent to a circle. And they have to be tangent, obviously, from the same exterior point. And are then, it means the segments are congruent. So for that picture, I actually call this my dunce cap picture. The way the diagram has it drawn in your book, I'll show you that first, and then I'll tell you why I call it the dunce cap picture. If we had 2 points of tangency, top and bottom here of, we'll call them B and C, which is what your book calls them, and these two segments are tangent to the circle from an exterior point, which we'll call A. If they really truly are tangent, then what we can assume is that those lengths are always going to be the same. So we can assume that segment AB is going to be congruent to segment AC. The reason I call this the dunce cap picture is because it kind of looks like a person with a cone-shaped dunce cap on the top of their head if you were to draw it in a vertical orientation there. So that's how I think of it. So that's what we have for our vocabulary for this section.